August 12, 1944, Marine Corps POW Facility, Agana, Guam. Lieutenant Commander Harold F. Stayson's boots crunched across the coral gravel as he approached the makeshift interrogation tent where 3 captured Japanese naval aviators sat under guard. Stayson carried a clipboard thick with intelligence questionnaires, but his mind kept returning to something one of the prisoners had said during preliminary questioning the day before, something that seemed at first like a translation error. "They think our fighters are made of wood." The statement made no sense. Stayson had served as an intelligence officer with Task Force 58 since February. He'd watched F6F Hellcats launch from carrier decks in weather that would ground lesser aircraft. He'd seen them return from combat with holes punched through wings and fuselage that would have destroyed any wooden structure. The idea that Japanese pilots, experienced combat aviators who'd fought American aircraft for nearly 3 years, believed U.S. fighters were wooden seemed absurd. Yet here sat Flight Petty Officer First Class Jigoro Irie, 26 years old, shot down 2 days earlier during the final Japanese air resistance over Guam. Through the interpreter, Irie had repeated the claim. American aircraft, he insisted, were constructed primarily of wood and fabric, like training aircraft. This explained their poor performance in combat. This explained why they lacked the agility of the Zero. Stayson decided to test the theory directly. "Ask him," Stayson instructed the interpreter, "what the Hellcat is made of." The interpreter translated. Irie responded without hesitation, his voice matter-of-fact. "He says the F6F fuselage is wooden. The wings are fabric over wooden frames, perhaps some metal components in the engine area, but primarily wooden construction, like your observation aircraft." Stayson felt something shift in his understanding. This wasn't a translation error. This wasn't ignorance from a single pilot. If Irie believed this, if Japanese naval aviators operating from carriers, fighting American aircraft throughout the Pacific, genuinely believed the industrial might of the United States produced wooden fighters, then the intelligence failure on the Japanese side dwarfed anything Stayson had previously documented. "Would he like to see one?" Stayson asked. "We have several captured Zeros on the airfield, and we have Hellcats. I can arrange a comparison." The interpreter translated. Irie's expression showed interest, the first emotion Stayson had seen from the prisoner since his capture. What happened next would provide American intelligence with a window into one of the most catastrophic miscalculations in military history. The Japanese High Command had built its entire Pacific air strategy on assumptions about American industrial capability that were not merely wrong, but wrong by an order of magnitude that defied comprehension. They had sent their pilots into battle, believing they faced opponents flying wooden aircraft produced by a nation that lacked the technical sophistication for mass production of all-metal fighters. The reality, which Irie would confront within the hour, was so different from Japanese assumptions that it would break something fundamental in the pilot's understanding of the war. Because the United States hadn't just built metal aircraft, it had built them by the tens of thousands, rolling them off assembly lines faster than Japan could produce trainers, powered by engines that dwarfed anything in the Japanese inventory, armored and equipped with a philosophy that said American pilots were too valuable to sacrifice. Stayson didn't know it yet, but he was about to document the moment when Japanese faith in Yamato Damashi, the spirit of Japan, confronted the industrial reality of American mass production. And spirit, no matter how fierce, could not stop assembly lines. The journey to Irie's shocked realization had begun 3 years earlier, when Japanese naval aviation dominated the Pacific, with a technological edge so pronounced that American pilots called the first 6 months of the war the desperate time. December 7, 1941, 0753 hours, Pearl Harbor, Oahu, territory of Hawaii. The A6M Zero fighters that provided escort for the attacking bombers that morning represented the cutting edge of carrier aviation. They outperformed every fighter the United States could field. They could outclimb, outturn, and outrange American aircraft by margins that seemed to defy physics. The Zero Model 21 carried into combat that morning had a maximum speed of 533 kilometers per hour, a service ceiling of 10,000 meters, and a combat range of 1,600 kilometers. More importantly, it could sustain turning combat at speeds and angles that would stall American fighters. Powered by the Nakajima Sakae 12 engine, producing 940 horsepower, the Zero achieved these capabilities through a design philosophy that prioritized performance above all else. The mathematics were elegant. Chief designer Jiro Horikoshi had received requirements from the Imperial Japanese Navy in 1937 that seemed impossible. Build a carrier-based fighter that could escort bombers to China from bases in Formosa, a round-trip distance exceeding 2,000 kilometers, while maintaining air superiority against any opponent. The Zero had to outperform land-based fighters while operating from carrier decks. Horikoshi's solution was radical weight reduction. The Zero Model 21 that entered service in July 1940 weighed just 1,680 kilograms empty. To achieve this weight, Horikoshi used a new aluminum alloy called Extra Super Duralumin, employed extensive weight-saving measures in every component, and made one critical decision. He eliminated armor protection for the pilot and fuel tanks. The fuel system used bare metal tanks with no self-sealing capability. A single armor plate behind the pilot's seat weighed 65 kilograms and would have reduced range by approximately 200 kilometers. Horikoshi made the calculation that range and performance mattered more than protection. In 1940, this seemed logical. Japanese pilots were the elite of naval aviation, trained to avoid being hit. The Zero's maneuverability would be its defense. The results in early combat seemed to validate everything. April 18, 1942, over Lae, New Guinea, 27 Zeros from the Tainan Air Group engaged 16 P-39 Airacobras and P-40 Warhawks. The Japanese pilots destroyed 11 American fighters without a single Zero loss. The Americans couldn't maneuver with the Zeros. They couldn't escape. Their heavier, less agile fighters fell from the sky, while the Zeros danced through defensive formations with impunity. May 4th to 8th, Battle of the Coral Sea. Zero pilots claimed 69 Allied aircraft destroyed in the first carrier battle in history. U.S. Navy pilots flying F6F Wildcats, the best carrier fighter America could deploy, found themselves outmatched in every performance category except diving speed and structural strength. Lieutenant Commander John S. Jimmy Thatch, leading Fighter Squadron VF-3, developed a defensive tactic called the Thatch Weave, specifically to survive encounters with Zeros. The tactic used pairs of Wildcats flying a weaving pattern to provide mutual support. It was effective at preventing losses. It did not allow Wildcats to defeat Zeros. It merely allowed them to survive. The Zero could outmaneuver us at any speed, Thatch reported after Coral Sea. Our only advantages were armor and diving speed. We could not engage in turning combat. We could not climb with them. We could not sustain combat unless we maintained very specific tactical geometry. The pattern repeated across the Pacific through mid-1942. Zeros, escorting bombers, struck Darwin, Colombo, Trincomalee, Port Moresby, Midway, and the Aleutians. They swept Allied fighters from contested airspace with casualty ratios that favored Japanese pilots by margins of 5-to-1 or higher. The Zero seemed invincible. Japanese intelligence reports from this period reflect confidence bordering on contempt for American aviation capability. A translated intelligence summary from the Combined Fleet Staff, dated May 1942, assessed American fighters as inferior in all categories except structural strength, and concluded that enemy industrial capability focuses on quantity rather than quality. Their aircraft employ obsolete design philosophy and lack the refinement necessary for modern air combat. This assessment contained one accurate observation: American fighters were indeed structurally stronger, but missed its significance entirely. Japanese intelligence interpreted structural strength as evidence of crude design. They believed American engineers lacked the sophistication to build lightweight, agile aircraft. They assumed U.S. fighters were heavier because American industry couldn't work aluminum to fine tolerances. The assumption extended to beliefs about construction methods. Multiple Japanese intelligence documents from 1941 to 1942 reference American use of partial wooden construction in combat aircraft. These references appeared to stem from confusion about pre-war American trainers and observation aircraft, which did use fabric and wood, combined with Japanese assumptions about American industrial limitations. Japanese naval attachés in neutral countries during the late 1930s had observed American aviation production but misinterpreted what they saw. They reported that American aircraft companies still relied on craft production methods rather than true mass production. They noted that Boeing, Douglas, and other manufacturers produced aircraft in relatively small numbers compared to the scale of American automobile production. These observations were accurate for the late 1930s, but failed to anticipate the transformation coming to American aviation. In 1939, U.S. aircraft production totaled 5,856 aircraft of all types. Japanese observers correctly noted this was far below automobile production levels and concluded that America lacked the industrial capacity to mass-produce modern combat aircraft. What they missed was the revolution beginning in American aviation factories. June 3, 1942. Grumman Aircraft Engineering Corporation Facility, Bethpage, Long Island, New York. The first production F6F Hellcat prototype rolled out for testing. The Hellcat was designed specifically to defeat the Zero. Every specification reflected lessons from the first 6 months of combat. The design requirements came directly from combat pilots. The Navy's Bureau of Aeronautics wanted a fighter that could match the Zero's climb rate and combat ceiling while providing American advantages in speed, firepower, and, critically, survivability. Chief designer Leroy Grumman and his team had 8 months to deliver. The Hellcat that emerged was the anti-Zero. It mounted the Pratt Whitney R-2800 double wasp engine, producing 2,000 horsepower, more than twice the Zero's power. This brute force approach gave the Hellcat a maximum speed of 605 kilometers per hour and a climb rate of 1,039 meters per minute. The Zero could still turn inside the Hellcat, but the Hellcat could dictate engagement terms through superior speed and climb. More importantly, Grumman built the Hellcat to bring pilots home. The aircraft incorporated 212 pounds of armor plate protecting the pilot from ahead, behind, and below. The fuel system used self-sealing tanks that could sustain multiple hits without fire. The oil cooler had armor protection. Even the oil tank had a self-sealing bladder. The structure was all metal, stressed skin construction, using 24ST aluminum alloy. The wings used a single spar design with heavy-gauge skin that could sustain battle damage that would destroy a Zero. Wind tunnel testing deliberately overstressed the airframe to ensure it could survive violent maneuvers and combat damage. The Hellcat weighed 4,152 kilograms empty, nearly 2.5 times the Zero's weight. Every kilogram served a purpose: more fuel, more ammunition, more armor, more structure. The Hellcat sacrificed the Zero's elegant efficiency for overwhelming capability and survivability. Grumman designed the Hellcat for mass production from the beginning. Every component was engineered for rapid manufacturing. The company planned to produce them not by dozens, but by thousands. In June 1942, as the first prototype tested, Grumman was already expanding its production facilities to accommodate assembly lines that would rival automobile plants in scale. Japanese intelligence knew none of this. They knew the Hellcat existed. American aviation magazines had published articles about it. But they assessed it as another heavy, clumsy American fighter that would prove inferior to the Zero in combat. The idea that America was preparing to mass-produce a fighter specifically designed to defeat the Zero, built with protection systems that would sacrifice Japanese advantages, incorporating an engine producing twice the Zero's power, never appeared in Japanese intelligence estimates. They simply couldn't conceive that America would or could build such an aircraft in the quantities necessary to change the war. Through the last months of 1942 and into early 1943, the Zero continued to dominate tactical engagements throughout the Pacific. But the pattern was becoming more complex in ways Japanese commanders failed to recognize. August 7, 1942, the Guadalcanal campaign began. Zero fighters from Rabaul flew 560 nautical miles to contest the American landing, engaging F4F Wildcats from Henderson Field and carrier escorts. The Zeros maintained their tactical superiority in individual combat, but for the first time faced a problem more fundamental than combat performance: logistics. The Zero's remarkable range came with a hidden vulnerability. The 1,600-kilometer combat radius required pilots to fly missions lasting 5 to 6 hours, including combat time. Pilots departed Rabaul at dawn, fought over Guadalcanal, and returned to base in darkness, exhausted. The physical and mental strain degraded performance. Pilots made mistakes born of fatigue. More critically, the long missions exposed Zeros to attrition through mechanical failure and navigation error. Aircraft lost to engine problems over open ocean never appeared in combat statistics, but they depleted Japanese squadrons as surely as aerial combat. Throughout the Guadalcanal campaign, the Tinian Air Group, the elite unit that had massacred Allied fighters over Leh, lost more aircraft to operational causes than to enemy action. But the Zeros kept coming. Through August, September, and October 1942, they maintained pressure on Henderson Field. American pilots continued to suffer from the Zero's performance advantages. Yet, something was changing in the quality of American resistance. Wildcat fighters were learning. The thatch weave became standard doctrine. New tactics emphasized using the Wildcat's superior diving speed and structural strength. Pilots learned to avoid turning combat, to maintain energy, to force engagements into vertical geometry where American fighters had advantages. More significantly, new aircraft were entering service. The Lockheed P-38 Lightning reached the Pacific in November 1942. The F-4U Corsair entered Marine Corps service in February 1943. Both aircraft could compete with the Zero in ways the Wildcat couldn't. They were faster, more powerful, more heavily armed, and far more survivable. January 1943. Grumman delivered the first production F6H Hellcats. The factory at Bethpage was producing 5 aircraft per day and accelerating. Grumman planned to reach peak production of 500 Hellcats per month by late 1943. Japanese intelligence reports from this period show no awareness of the coming storm. A combined fleet intelligence summary from March 1943 assessed American fighter development as incremental improvements to existing types, and concluded that the enemy continues to rely on heavy construction and superior numbers rather than aircraft performance. The report noted the Hellcats' existence, but assessed it as another example of American preference for armor and firepower over maneuverability. The assessment reflected a fundamental misunderstanding of American design philosophy. Japanese intelligence interpreted protection systems as evidence of defensive thinking and inferior pilot quality. They believed American pilots needed armor because they lacked the skill to avoid being hit. They saw self-sealing fuel tanks as compensation for poor tactical discipline. This interpretation missed the essential point. American designers valued pilot lives more than marginal performance advantages. The U.S. Navy calculated that an experienced pilot was worth more than any aircraft. Losing pilots meant losing accumulated combat experience, training investment, and tactical knowledge. Better to build heavier aircraft that brought pilots home than light aircraft that created casualties. Japanese doctrine took the opposite view. The pilot's life mattered less than mission success. Aircraft existed to achieve tactical objectives, not to protect crews. If achieving victory required accepting higher casualties, that was the necessary price. Bushido, the warrior code, demanded that Japanese pilots embrace death in service to the emperor. This philosophical difference was about to produce strategic consequences neither side fully anticipated. April 18, 1943. Operation Vengeance. 16 P-38 Lightnings from Henderson Field intercepted Admiral Isoroku Yamamoto's transport flight over Bougainville. The mission required a 700-kilometer flight at wave-top altitude to avoid radar detection, precise navigation to intercept Yamamoto's aircraft at exactly the right moment, and enough fuel remaining to fight and return home. The P-38s accomplished what would have been impossible for Zeros. They flew the mission profile, intercepted both transport aircraft, shot down Yamamoto's bomber, and returned to base. The mission succeeded because the P-38 combined long range with high speed, heavy firepower, and enough structural strength to fly the entire mission at maximum continuous power. The Japanese High Command recognized Yamamoto's death as a devastating blow to morale. What they failed to recognize was what the mission revealed about American capability. The U.S. military could now project fighter power across distances that previously belonged exclusively to Japanese aviation. The range advantage that had defined Zero superiority was evaporating. May 1943. American aircraft production reached 7,742 aircraft for the month, more than Japan produced in all of 1942. The numbers included 316 F6F Hellcats, 282 F4U Corsairs, 349 P-38 Lightnings, and 417 P-47 Thunderbolts. Every one of these fighters was all-metal, heavily armed, armored, and powered by engines producing 1,850 to 2,000 horsepower. Japanese production in May 1943 totaled approximately 1,350 aircraft of all types, including 143 A6M Zeros. Japanese factories were approaching maximum sustainable output. They lacked the machine tools, the aluminum supply, the skilled workforce, and the production floor space to expand further. The strategic mathematics were becoming impossible. Japan needed to achieve decisive victory quickly before American production advantage translated to overwhelming numerical superiority. But achieving decisive victory required winning battles, and winning battles was becoming harder as American fighters improved. June 1943. The first F6F Hellcats reached operational squadrons. VF-9 aboard USS Essex received their aircraft in May and began intensive training. The pilots, many of them combat veterans with Wildcat experience, immediately recognized the Hellcats' advantages. "It was a revelation," Lieutenant Junior Grade Hamilton McWhorter later wrote. "We've been fighting an aircraft that were inferior to the Zero in almost every category except diving speed. Now we had an aircraft that could fight the Zero on equal terms and beat it." The Hellcat could outclimb, outdive, outrun, and outgun the Zero. The only thing the Zero could do better was turn, and we'd learned not to get into turning fights anyway. The first Hellcat combat sorties came in August 1943 during the Marcus Island raid. The results were promising but not decisive. The Hellcats encountered limited Japanese opposition. The real test would come in November, when carrier strikes hit the Gilbert Islands as preparation for amphibious landings. But before the Hellcat could prove itself in major combat, one more element needed to fall into place: pilot training that could exploit the Hellcat's capabilities. The United States was in the process of creating the most comprehensive pilot training program in military history. By mid-1943, the U.S. Navy was producing 2,000 newly qualified pilots per month. These pilots received 300 hours of flight training before assignment to operational squadrons, then received additional training in their combat aircraft before deployment. Compare this to Japanese training. By 1943, Japan was reducing flight training time because of fuel shortages and the need to replace combat losses quickly. New pilots reached operational units with 100 to 150 hours of flight training, less than half the American standard, and received minimal training in type before entering combat. The quality gap was widening. American pilots arrived in combat squadrons with more training, flying better aircraft, supported by better logistics, backed by industrial production that could replace losses overnight. Japanese pilots arrived in combat with less training, flying aircraft designed to a different philosophy, supported by a logistics system that was starting to fracture under American submarine interdiction. November 20, 1943, the Gilbert Islands invasion began. Hellcats from Task Force 50 flew combat air patrol and strike escort missions over Tarawa and Makin. The Japanese opposition was limited. Most Japanese aircraft in the Gilberts were destroyed on the ground by the preliminary bombardment, but the Hellcat pilots who did encounter Zeros found the combat almost disappointingly one-sided. "We had every advantage," recalled Lieutenant Commander Edward O'Hare, commanding VF-6. "We were faster, we could climb with them, we could dive away if things got difficult. The Zero could still turn inside us, but we'd learned not to get into turning fights. We'd make one pass, use our speed to extend out of range, then come back with energy advantage. The Zeros couldn't effectively counter the tactic." The Gilbert Islands operation cost Japan 82 aircraft. American losses totaled 35 aircraft, with most losses attributed to anti-aircraft fire rather than air combat. The kill ratio in air-to-air combat favored the Americans by approximately 4-1. Japanese after-action reports noted the presence of a new American fighter with improved performance, but assessed it as marginally superior to previous types. The reports recommended maintaining aggressive tactics and exploiting the Zero's turning advantage. This recommendation revealed how completely Japanese commanders misunderstood the new tactical reality. The Zero's turning advantage no longer mattered because American pilots had learned not to turn. The entire tactical system built around Zero performance was becoming obsolete. But Japanese doctrine, Japanese training, and Japanese production were all committed to the Zero and its philosophy. Changing course would require admitting that 3 years of war had been fought with fundamental assumptions that were wrong. It would require completely restructuring aircraft production, retraining pilots, and abandoning tactics that had brought victory in 1941 to 1942. The institutional momentum was too great. Japan continued building Zeros, training pilots to exploit the Zeros' turning ability, and sending them into combat against opponents who had learned to nullify that advantage. December 1943. Grumman produced 605 Hellcats. Monthly production was still accelerating toward the target of 500-plus aircraft per month. General Motors had licensed the Hellcat design and was preparing to begin production at a second facility. The U.S. Navy's BuAer was projecting total Hellcat production would exceed 10,000 aircraft, more than the entire Japanese Naval Air Force. The storm was about to break over the Japanese defensive perimeter, and when it came, Japanese pilots would learn truths about American industrial capability that would shatter every assumption they'd carried into the war. February 17, 1944. Operation Hailstone. Task Force 58, under the command of Vice Admiral Mark A. Mitcher, launched a massive carrier strike against the Japanese naval base at Truk Lagoon in the Caroline Islands. The attacking force included 9 fleet carriers and 6 light carriers carrying 500 F6F Hellcats among their aircraft complement. The raid began at 0630 hours. Hellcats swept over Truk at altitudes from sea level to 6,000 meters, attacking Japanese aircraft on the ground and in the air. The Japanese had 365 aircraft at Truk when the raid began. By nightfall on February 18, American pilots claimed 275 Japanese aircraft destroyed, 127 in the air, 148 on the ground. American losses totaled 25 aircraft, with 17 lost to anti-aircraft fire and 8 lost in air-to-air combat. The air-to-air kill ratio was approximately 16-1 in favor of the Americans. Lieutenant J.G. Alexander Vrachu from VF-16, flying from USS Lexington, shot down 4 Japanese aircraft in a single mission on February 17. His combat report provides insight into why the Hellcat dominated. Quote, "I engaged 3 Zeros at 8,000 feet, selected the trailing aircraft and closed to 300 yards, opened fire with all 6.50 caliber machine guns, observed strikes on fuselage and wing route. Target aircraft burst into flames immediately and fell away. Selected second aircraft and repeated attack. This aircraft also caught fire and descended. The third Zero attempted to turn into me. I used my speed advantage to extend, climbed 2,000 feet, and came back down with energy advantage. Fired a 3-second burst from dead astern. Target exploded. Time elapsed from first engagement to third kill, approximately 4 minutes. Notice what Vrachu doesn't mention: turning combat. He doesn't try to outturn the Zeros. He uses speed, climb rate, and firepower. The 6.50 caliber machine guns each fired 800 rounds per minute. A 3-second burst delivered approximately 240 bullets. The Zero's unarmored structure couldn't survive that punishment. Compared Vrachu's experience to what was happening to Japanese pilots. Flight Petty Officer First Class Saburo Sakae, one of Japan's highest-scoring aces with 64 confirmed victories, encountered Hellcats in early 1944. Sakae survived the war and published memoirs that provide the Japanese perspective on fighting the new American fighters. Quote, "The Hellcat was a completely different opponent from the Wildcat. It could do everything we could do and do it faster. When we tried our standard tactics, close rapidly and force a turning fight, the Hellcat pilots would simply use their superior speed to extend out of range. Then they would climb above us and come back down with altitude advantage. We couldn't climb with them. We couldn't run from them. And if they hit us even once or twice, our aircraft caught fire." Unquote. Sakae identified the core problem. The Zero's lack of protection transformed any hit into a potentially fatal hit. American pilots could absorb dozens of hits and return to base. Japanese pilots catching a single burst of .50 caliber fire would likely die. Quote, "We called the Zero the flying lighter," Sakae wrote. "One spark and it ignited." American pilots learned to aim for the wing roots where the fuel tanks were located. A single burst there, and the aircraft became an inferno. Our pilots had no chance to bail out. The fire consumed the aircraft in seconds." Unquote. The nickname spread through Japanese fighter units. Raita, the lighter. Some pilots called it the one-shot lighter because it took only one good burst to ignite it. The gallows humor reflected growing fear among Japanese aviators. But the nickname didn't appear in official reports. Japanese military culture didn't permit acknowledging such vulnerabilities. After-action reports continued to claim tactical successes and attribute losses to numerical superiority rather than technical inferiority. The truth was becoming harder to hide. March 30th, 1944. A6M Zero, tail number 5357, flown by Flight Petty Officer Toyoaki Yoshio, made a forced landing on Bougainville after sustaining battle damage. The pilot survived and evaded capture. The aircraft fell into American hands intact, the first Zero captured in flyable condition. Navy and Marine Corps pilots test flew the Zero extensively over the following weeks. The test reports provided complete performance data on the Zero for the first time and confirmed what combat experience had indicated. The Zero was an excellent dogfighter with exceptional range, but it was fragile, underpowered compared to current American fighters, and lacked any protection for the pilot or fuel system. The detailed examination of Zero 5357 revealed construction techniques that shocked American engineers. Lieutenant Commander Frederick J. Trapnell led the technical evaluation team. His report, dated April 15, 1944, documented findings that would be distributed to every squadron intelligence officer in the Pacific Fleet. The A6M Zero examined at Bougainville represents a design philosophy fundamentally different from American practice, Trapnell wrote. The aircraft achieves its performance through extreme weight reduction carried to a degree that compromises structural strength and pilot survivability. The report detailed specific findings. The fuselage skin gauge measures 1.0 to 1.2 millimeters in most areas, approximately half the gauge used in American fighters. The wings use single-spar construction with minimal ribbing. The fuel tanks are unprotected metal with no self-sealing capability or inerting system. There is no armor protection for the pilot except a single 8mm plate behind the seat back. There is no armor protection for the engine, oil cooler, or other vital systems. The aircraft structure cannot sustain significant battle damage. Hits that would cause minor damage to an F6F will cause critical failure in the Zero. The wings will fail under loads that American fighters routinely sustain. The thin fuselage skin tears easily under stress. The fuel system is the aircraft's greatest vulnerability. Any hit to the wing fuel tanks will cause immediate fuel leak. The tanks will not self-seal. Any incendiary or tracer ammunition will ignite leaking fuel. The pilot's position is directly forward of the main fuel tank with no firewall protection. In the event of fuel fire, the pilot has approximately 5 to 10 seconds to bail out before fire blocks the escape path. The report concluded, "The Zero is optimized for a specific combat scenario. Long-range escort missions fought by highly trained pilots who can use the aircraft's maneuverability to avoid being hit. Against such tactics, American fighters must refuse turning combat and exploit advantages in speed, climb rate, and diving performance. Given equal pilot skill and proper tactics, the F6F holds decisive advantages over the Zero in almost all combat situations." The report was classified secret and distributed to squadron intelligence officers throughout the Pacific. Pilots received briefings emphasizing the Zero's vulnerabilities. Aim for the wing roots. Set your guns to converge at 300 yards. A 3-second burst from astern will destroy a Zero. Do not attempt to turn with Zeros. Use speed and altitude to control engagement geometry. But even as American pilots learned to exploit Zero vulnerabilities, Japanese pilots remained largely unaware of American aircraft construction methods and capabilities. Captured Japanese documents from mid-1944 revealed persistent misconceptions about American fighters. A Japanese Naval Air Force intelligence bulletin dated May 1944, captured at Saipan, included this assessment of the F6F. The F6 type fighter possesses improved performance over the F4F due to increased engine power. The aircraft maintains the American preference for heavy construction. Performance is achieved through brute force rather than refined design. The aircraft likely uses partial wooden construction in wing structures to reduce weight, similar to observed American practice in other types. Japanese fighters maintain superiority in maneuverability and range. This assessment, written in May 1944, after the Hellcat had proven its dominance at truck and in numerous other engagements, still included the assumption that American fighters used wooden construction. Japanese intelligence had not updated its understanding of American aircraft since 1941. The belief persisted because Japanese pilots shot down rarely survived to provide accurate reports. Japanese intelligence had limited access to intact American aircraft for examination, and the institutional assumption that American industry was inferior to Japanese precision manufacturing was deeply embedded in military culture. The assumption was about to be tested in the largest carrier battle in history. June 1920, 1944, the Battle of the Philippine Sea, the Great Mariana's Turkey Shoot. Task Force 58, 15 carriers, 956 aircraft. Japanese Mobile Fleet, 9 carriers, 473 aircraft. Vice Admiral Ozawa launched 4 massive waves totaling 326 aircraft. The plan: strike American carriers, refuel at Guam, return to the fleet. Every assumption failed. American radar detected the first wave at 150 miles. Task Force 58 launched 220 Hellcats to intercept. What followed was slaughter. The first wave, 69 aircraft launched. 42 shot down before reaching the fleet, only 27 returned. The second wave, 128 aircraft launched, 98 destroyed. American pilots reported combat was so easy it was embarrassing. The Zeros fell in groups, burning as they tumbled into the sea. Commander David McCampbell shot down 7 Japanese aircraft personally. His report noted, multiple enemy aircraft observed catching fire from short bursts. Self-sealing fuel tanks appeared to be absent from enemy fighters. Lieutenant George R. Carr, with only 47 hours in the Hellcat, destroyed his first Zero in 90 seconds. When the Zero pilot tried to turn, the classic Zero tactic, Carr refused to follow. He used speed to extend, climbed above, and came back down with altitude advantage. The Zero couldn't match his climb rate. Carr fired a 4-second burst into the wing root. The Zero caught fire immediately. This was the pattern across the entire battle. American pilots with the Hellcat formula, Refuse turning combat, use speed and climb, aim for wing routes, destroyed Japanese aircraft with mechanical efficiency. By June 21, Japan lost 373 aircraft, 445 aircrew, and 3 carriers. American losses, 29 aircraft, 23 crew. Kill ratio, 13-1. The Imperial Japanese Navy's carrier aviation had effectively ceased to exist as a strategic force. Admiral Ozawa's report attributed losses to overwhelming enemy numerical superiority. It didn't mention, perhaps didn't recognize, that American industry was producing Hellcats at 500 per month, while Japan struggled to build 250 Zeros monthly. America was training 2,000 pilots per month. Japan was training 450. The mathematics of attrition had become impossible. Even if Japanese pilots achieved parity in combat, which they weren't, they would still lose through sheer production advantage. The system was collapsing. But most Japanese pilots still didn't understand what they were really fighting against. That knowledge would come in August 1944, when captured pilots on Guam saw American aircraft up close. The Zero and Hellcat embodied 2 completely different answers to the same question: how do you build the best carrier fighter? Designer Jiro Horikoshi faced impossible requirements in 1937. Build a fighter with 1,600-kilometer range, superior maneuverability, and heavy armament, all from a carrier deck. The mathematics were brutal. To achieve that range, the aircraft needed 518 liters of fuel. With engine, weapons, and pilot, Horikoshi had only 723 kilograms left for the entire airframe. His solution: eliminate everything non-essential. Fuselage skin just 1.0 to 1.2 millimeters thick, half the American standard. Single spar wings, no armor except one thin plate behind the pilot. No self-sealing fuel tanks, no fire suppression. The protection systems alone would have weighed 320 kilograms and reduced range by 35%. The philosophy: skilled pilots don't need armor. Maneuverability is protection. The Zero would win by not getting hit. Result: 1,680 kilograms empty, 533 km/h top speed, incredible agility, 1,600 kilometers range. A masterpiece of weight optimization, but with zero margin for growth and one fatal vulnerability: any hit to the fuel tanks meant instant fire. America's approach was opposite. Leroy Grumman built the Hellcat around a 2,000-horsepower R-2800 engine, twice the Zero's power. This gave him 1,600 kilograms for the airframe instead of 723. He used it to build a fighter that brought pilots home. 96 kilograms of armor plate protecting the pilot from all directions. Self-sealing fuel tanks that sealed bullet holes automatically. Armored oil systems, fire suppression, multi-spar wings that could sustain massive damage, structure stressed to 7.5 G, far beyond normal requirements. The philosophy: pilots are more valuable than aircraft. Performance matters, but survivability matters more. Build it heavy, power through with brute force. Result: 4,152 kilograms empty, 2.5 times the Zero's weight, but faster, equal climb rate, and nearly indestructible. The philosophical gap was profound. Japan asked, "What must we sacrifice?" America asked, "How much power do we need to avoid sacrifice?" One approach worked for a short war with skilled pilots against inferior opponents. The other worked for sustained industrial warfare, where attrition decided outcomes. The numbers tell the story of what happened when Japanese philosophy met American reality. After the Great Mariana's Turkey Shoot in June 1944, Japanese naval aviation effectively ceased to exist as a strategic force. The mobile fleet lost 373 aircraft and 445 trained aircrew in 2 days. American losses: 29 aircraft, 23 crew. Kill ratio: 13-1. But individual battles only illustrated the larger pattern. Throughout the second half of 1944 and into 1945, Zeros continued fighting Hellcats with predictable results. Lieutenant Commander Herbert Huck described the typical engagement. You'd get on a Zero's tail, fire a 2 or 3 second burst into the wing roots, and the damn thing would explode. Not catch fire and burn, explode. The fuel vapors would ignite and blow off the wing. We rarely saw successful bailouts. They didn't give pilots time to get out. Japanese ace Saburo Sakai, who survived the war, described it from the other side. We called the Zero the flying lighter. One spark and it ignited. American pilots learned to aim for the wing roots where the fuel tanks were. A single burst there and the aircraft became an inferno. Our pilots had no chance to bail out. The nickname spread: Raita, the lighter, the one-shot lighter. The gallows humor reflected growing terror among Japanese aviators. Meanwhile, Hellcat pilots routinely returned from missions with battle damage that would have killed Zero pilots. 12 7.7mm holes in a wing? Minor damage. 20mm cannon shell through the oil cooler? Armor closed automatically, made it home. Engine fire from enemy hit? Fire suppression worked, landed safely. The protection systems worked exactly as designed. American pilots who were shot down had 40% survival rates. Japanese pilots who were shot down had 10% survival rates. Most died when their aircraft burned too quickly to escape. By August 1944, when captured pilots examined intact Hellcats on Guam, the mathematical outcome was already determined. Japan had lost the industrial war. What remained was grinding execution of impossible mathematics. More missions, more combat, more irreplaceable losses. The Zero's final operational role was kamikaze attacks, suicide missions where protection systems were irrelevant. The aircraft didn't need to bring pilots home because they weren't coming home. But even kamikaze attacks couldn't stop American advances. The industrial disparity was too great. The production numbers reveal the impossible mathematics Japan faced. Zero production 1940 to 1945, 10,939 aircraft total. Peak production 237 per month in 1944. Hellcat production 1942 to 1945, 12,275 aircraft total. Peak production 664 per month in March 1945. The Hellcat was manufactured for 32 months. The Zero was manufactured for 58 months. The Hellcat exceeded total Zero production in half the time. At peak efficiency, Japan built 8 Zeros per day across all factories. America built 22 Hellcats per day across 2 factories, while simultaneously producing Corsairs at 15+ per day, P-38s at 11+ per day, P-47s at 20+ per day. American aviation production exceeded Japan's entire aircraft industry, all types combined. Combat record: F6F Hellcat, 5,223 confirmed victories, 270 lost in aerial combat. Kill ratio 19-1. A6M Zero, approximately 1,500 confirmed victories, approximately 3,200 lost in air-to-air combat. From mid-1943 onward, the kill ratio reversed and deteriorated steadily through 1945. Pilot survival. U.S. Navy trained 60,000 pilots, lost 4,900 killed in Pacific. Survival rate when shot down, 40%, rescued or survived as POWs. Imperial Japanese Navy trained 16,000 pilots, lost 12,000 killed. Survival rate when shot down, 10%. Most died when aircraft burned. The difference reflected design philosophy. Hellcats absorbed damage and gave pilots time to escape. Zeros burned instantly, killing pilots before they could bail out. Was the Zero poorly designed? No, it was brilliantly designed to meet specific requirements under specific assumptions. Those assumptions proved wrong for the war Japan actually fought. The Zero assumed highly trained pilots, combat where range mattered more than protection, and opponents flying inferior aircraft. None held beyond 1942. The Zero couldn't adapt. No margin for adding protection. Attempts to improve it degraded performance. It was optimized so completely for original specifications that any change destroyed its advantages. The Hellcat had enormous growth potential. Improved engines, night-fighting radar, reconnaissance variants, all while maintaining or improving performance. The fundamental difference. Japanese designers asked, "What must we sacrifice?" American designers asked, "How much power do we need to avoid sacrifice?" One approach worked for a short war. The other worked for sustained industrial warfare where attrition decided outcomes. August 12, 1944. Agana Airfield, Guam. Jigoro Irie stood before the F6F Hellcat, his worldview shattered. He had believed American fighters were wooden and weak. The all-metal construction proved that wrong. He had believed American armor reflected poor pilot quality. The protection systems revealed a philosophy that valued pilot lives more than marginal performance. He had believed Japanese spirit could overcome material disadvantages. The production numbers, 9,000 American aircraft per month versus Japan's 1,600, proved spirit couldn't stop assembly lines. Lieutenant Commander Stossen's interrogation reports documented this pattern across multiple captured pilots. Japanese aviators consistently expressed shock at what America had built. The intelligence assessment concluded, Japanese High Command appears to have fundamentally miscalculated American industrial capability by an order of magnitude. The miscalculation wasn't surprising. It reflected institutional biases embedded in Japanese strategic thinking. That American mass production meant quality had to suffer. That American individualistic culture couldn't harness industrial power effectively for war. That superior Japanese spirit could overcome material disadvantages. These assumptions were comforting. They justified the Pacific War's premise: strike hard early, achieve victory before American industry mobilized, defend a perimeter too costly to breach. But every assumption proved wrong. American mobilization was faster than imagined. American equipment was superior in quality while being produced in crushing quantities. American forces absorbed casualties and kept advancing. By August 1944, the outcome was determined. The Marianas had fallen. The combined fleet was broken. American submarines had devastated Japanese merchant shipping. The industrial war was lost. Jugoro Irie survived as a POW and returned to Japan in 1946. In a 1973 interview, he reflected on his realization at Guam. "When I saw inside the Hellcats' wing and understood what the Americans had built, I knew we had lost. Not just the battle, the war, and perhaps had always been going to lose it. We were fighting with the tools of the war we wanted. They were fighting with the tools of the war that actually existed. They understood industrial warfare. We didn't." The lesson extends beyond Zero versus Hellcat. Wars are not won by the most elegant solutions to tactical problems. Wars are won by correctly identifying the conflict's nature and marshaling resources appropriately. Japan identified the Pacific War as a clash of wills where spirit could overcome material disadvantages. They designed weapons accordingly, optimized for performance within resource constraints, dependent on skilled operators, vulnerable to attrition. America identified it as an industrial struggle where production capacity would prove decisive. They designed weapons accordingly, over-engineered for survivability, mass-producible, forgiving of operator error, sustainable across years of attrition. The Zero was a samurai sword, elegant, deadly in skilled hands, requiring craftsmanship, irreplaceable when lost. The Hellcat was a factory-made rifle, crude by comparison, effective in average hands, mass-produced, replaceable at will. In industrial warfare, factory-made rifles defeat samurai swords, not because rifles are more elegant, but because factories produce rifles faster than battles destroy them. Japan sent the Zero into combat believing American fighters were wooden and weak. That belief persisted despite evidence, because accepting the truth meant acknowledging they'd started a war they couldn't win. The truth revealed itself eventually, on Guam, when captured pilots examined what had defeated them and learned what they'd really been fighting. By then, it was too late. And the Hellcats kept rolling off production lines, 22 per day, every day, until the surrender made them unnecessary. The Zero fought with elegance and spirit. The Hellcat fought with steel and industrial power. Steel won. It always does.